Hello, and what I'm going to do today is talk about global winds. This is a global wind worksheet that we worked on in class, at least in the odd classes, excuse me, even classes. Not so much odd because of all the disruptions we've had in our schedule this past week. But we're going to talk about wind belts, and we're going to talk about how the pattern actually builds up on the entire planet. So the first thing I want to do is I want to actually draw some highs and lows on this, and let me actually show you what a high and a low looks like. High is where pressure moves down and the weight of the air actually is higher than normal, and usually that's cold air signified by blue, and higher pressure signified by H. And low pressure, air has been moving on the surface of the earth, and notice that this is spinning in a clockwise direction, and I'll try to explain that down here in a second. It's been moving across the surface of the earth, and that's actually warmer than it is up top, so it actually warms up, signified by red, and it spins in a counterclockwise direction in and then moves up, being lighter than normal. So what we do is we actually say this is a low pressure, this is a high pressure. So what I'm going to do is I'm going to pick red, and if you take a look, we have these convection cells moving in a well, in clockwise and counterclockwise, but they actually move toward each other. It's upper level divergent and lower level convergent coming together and splitting apart, and that actually makes this a high. So I'm going to draw a couple of blue, maybe a few blue H's here. We'll explain why that's dry in a couple seconds. And we have the same thing down here. So I'll draw a few here too. That was not a good H. Let me draw one over here. And then we also have it up here at the top. So I'm going to draw one blue H up there. I'm going to draw one blue H down here. And then we have to do the same thing in this area where we actually see the air moving up. Draw some L's. And then down here where we also see the air moving up, draw a couple L's. And then up here at 60, right around 60, a couple of L's. And what we basically have is we have air moving in and moving out in a clockwise direction, and then we have air going up and moving in a counterclockwise direction. Let me show you how this works. Okay, so I'm going to pick blue. Air moves out from blue, and then it warms up, moving across the surface. And then it eventually gets as warm as it's going to get toward the lows. So air always moves from high to low, and the higher pressure this is, and this is actually saying this is high pressure, and it's a little lower pressure, and a little lower pressure, and a little lower, and a lower, and a lower, and a lower, and then the lowest pressure. So the higher this pressure gets, or the lower this pressure gets, or the bigger the gradient, the faster the wind. And if you were outside yesterday, today is Sunday the 23rd. October. If you were out yesterday, you actually experienced very high wind because we had a very high pressure, which we're under the influence today. Beautiful blue skies and puffy clouds, but not rain clouds, and cooler temperatures than we had yesterday. So we have more of this blue air. Okay, so let me show you the Coriolis effect. This is the Coriolis effect, and I have a picture of it up there, and I'll show that to you. But basically, if that red ball is drawing a straight line, and you see that red line is straight, but if you look at this rotating globe, the line that's being drawn on the globe is curved. Now this one is actually curved to the left. This is the southern hemispheres, and if I could actually flip this image, we would actually see it moving as a counterclockwise direction for the northern hemisphere, and we would see it actually moving the other direction. So let me move this out of the way. Let me scroll up here, and here's that red line with the lower southern hemisphere's spin moving to the left. And here's the red line with the blue line curving to the right for the northern hemisphere. So what basically happens is the pressure gradient says that I want to move straight out of a high and into a low, and then what the Coriolis effect says basically in the northern hemisphere, you can't. You have to go to the right. And then from here, you can't do that either. You have to go to the right. So what the in physics, you talk about vectors, and what basically happens is it says that you have to go this direction, and says that you have to go this direction. And eventually what happens is this air moves in a clockwise direction out of a high and moves in a counterclockwise direction into a low. And this is the way air moves. And that's what they're trying to show you in this picture. So if we go up here, it's coming out of a high, and what happens is that it can't move in a straight line. It has to curve to the right, and curving to the right going, actually let me show you up here. Curving to the right says they go this way, so what I'd like you to do is to draw some lines curving off that direction. And then also down here, except it's curving to the other direction. And then here it's moving in, except now we're going to curve not to the right, we're going to curve to the left. So it goes this way. And if this is going too fast, please stop me and go back and look at that diagram that I drew. And then same down here, it's coming out of the high, but it goes to the left, which basically means it moves this way. And coming out of the high, going to the right, goes this way. And coming out of the high, going to the left, goes this way. And what do we call these winds? Well, let me pick this color. These winds right here are called the trades. So number 4 are the trade winds. And you probably ought to write trade. You know what, I have a tablet for all this stuff too. These are the trade winds. Now these are actually coming out of the north, and if you take a look, these are the north. It's coming out of the northeast. These are called the northeast trade winds. And these down here are called the southeast. I guess I'd put dots there too. The southeast trade winds. And then up here we actually have what are called the westerlies. Okay, I moved over to my tablet, so hopefully I'll be able to read a little better. And these are actually coming out of the south, so these are called the southwesterlies. And these right here are coming out of the north, so these are the, I think maybe I was writing better with my mouse, westerlies. And if we actually go back over to here, so these are tropical easterlies, easter trade winds, and then we have all that stuff in there, but I'll show you on another diagram really soon. Okay, and then these up here are called the northeasterlies, and I actually put that there because I know I was going to be able to write there, and these down here are called the southwesterlies. So these are the trade winds, and primarily what happens is this Earth is straight up and down. We're really tilted 23.5 degrees, so all the stuff you see on the planet really is slanted this way. But basically we live up here in the westerlies. This is why our wind and weather pretty much comes from the west. We get our weather primarily from western Canada or western United States or the Gulf of Mexico down here, and it brings the stuff up over our location. This is what brings the hurricanes from Africa across the Atlantic Ocean, or actually maybe sometimes popping into the Pacific Ocean, and it moves this direction, and then eventually it moves so close up here that the westerlies pull the hurricane and maybe pull it off into the Atlantic or run it into the Gulf of Mexico and into the United States or whatever it does. But these are the global wind patterns. Okay, if I go into this location, this is actually called the horse latitudes. This is number 11. And you'll see this on the back of your sheet. And we have the same thing down here. Horse latitudes. And this is called the intertropical, and I'm just going to write IT, intertropical. It's in between the tropics. Cancer is located about right there, Capricorn about right there. Intertropical convergence, because the air is actually converging, zone, and this is wet. So let me show you why it's wet. If we actually watch air rising, clouds actually appear, they grow, and at some point they start raining. And then what does a high look like? And actually, there's the rain. And what does a high look like? Colder air moves down from above. That actually shrinks clouds, giving you more blue weather, or cool weather, sorry, but it's blue because it's relatively cool. If you take a look at this, we can have fair weather cumulus clouds and highs. We can also have cumulonimbus clouds, very high cumulus clouds, and lots of rain and lows. And it basically has to do with the fact that the air is either sinking and warming up or rising and cooling. And that's what you get here. So what you're going to get is a whole lot of clouds and rain in the tropics, the rainforests. You're also going to get a lot of clouds up here where we live, and get subtropical or subpolar rains. And then the same thing here. And then locations where you actually have the H's, these are dry. And this is where we get deserts. And if you pull up a thing of the United States, a map of the United States or a map of the world, let me see if I have that on here already. I don't really have a good picture in there, but it is, so it is in the video that you're watching for 3B, and this is for 3B. Okay, so do I have everything? I don't have, okay, so we haven't called these things. This is what's called the Hadley cell. Convective cell. Same thing over here. I'm just going to write HC. And the same thing down here. And these are where the two Hadley cells converge, surface, and they diverge upper level. And notice that the troposphere, this is actually called the troposphere boundary. It's called the tropopause. Tropopause is thinner up here by the pole because it's cold, but it's more dense, and it's taller, less dense here by the tropics because of the warmth. So the 10, these are also called the doldrums. And these are called the subpolar lows, and this is called the polar high. And the only thing we don't have this one yet. This is called the feral cell. And if you can't read my writing, you can flip your paper over because you have them right there. Hadley cell, the big one, feral cell smaller, and then the polar cell, this one up here by the pole, which is the shortest one because of the density. This is the polar cell. So let's see if we have these. Where the heck are the numbers? Okay, we have 10 ITC doldrums. We have 4, the northeast trade winds. We have 7, the southwest trade winds. We have 3, the polar cell. We have 2, the feral cell. 1, the Hadley cell. If we go down here, we have the southeast trades for 5. 6, we have the northwesterlies for 6. And then 7, we got 8, we got 9. Where the heck is 9? I don't know where 9 is. 9's on there somewhere. 10 we have, 11 we have. Okay, and what we don't have, oh, there's 9. This is what's called, and if I show you on the picture, and I'll show you another animation, we have what's called the polar jet, and we have the subtropic jet. And let me show you what the jets look like. This is the most current jet, and I got that by looking at, let me move this over here so I can get it back. By clicking this link here on your Word document, you can actually get this. And if you take a look at it, this is the position of the polar jet, and this is why we're going to get cooler temperatures. You can see that's Thursday and Friday. But we should actually get Sunday in here, and this is why we have cooler temperatures, because we have this cooler air coming from Canada. It may warm up a little bit midweek, but we're going to get some more cold air, and what will happen is this will keep getting lower and lower, and we'll actually experience colder and colder weather because we're moving from October into November, into December and January, and the subtropic jet is actually well below us, and that's what we get for summer when it brings up the moist air out of the Gulf. As the temperatures get warmer and warmer. Okay, the link that you see, this is the link that you see down below, and the Google link that's down there. And you can see there's the Hadley cell bringing cool air down to the about 30 degrees north. Warmer goes up and lots of clouds. That's the intertropic convergence zone. Then we throw on the Ferrel cell as it goes up, comes back up and comes here. This is the divergent upper level and convergent lower level. And then we throw in high altitude. There's the subpolar low and the polar high, throwing in the polar easterlies. Here are the southwesterlies. There are the northwesterlies. There are the southeast trades. There's the northeast trades. That we had in all those pictures. Okay, we throw the labels off, and you can see we get clouds up there where this air converges and goes up. They're just not showing you the Ferrel cell and the polar cell in this picture. Okay, so if I go down, here's where we actually have the horse latitudes. There's where we have the doldrums, where the air actually moves the horse latitudes toward the equator, and the strong, steady wind moves towards the equator, but it dies, called the doldrums. The westerlies blow from the west, easterlies blow from the east, and these actually bring storms across the United States, and this actually brings stormy weather usually to the westerlies. And then I think we scroll down, you can see all that stuff again. You can see the pressure belts here and the wind belts up there. You can see low-level convergence, high-level divergence, and clouds giving us wet weather. Upper-level convergence, lower-level divergence, bringing dry air, so the clouds actually, if they're there, they're not near as big, not near as high, not near as much water. And then we move up here again, where we get more rain, more wet, and then here we get maybe clouds, but drier weather. Same thing for, they're actually not showing you, I'm assuming this is north and this is south. So we get a little bit of clouds there, and then dry. Actually, that's not, why the heck did I draw that? Okay, because it's, here we get bigger clouds, and here we get the smaller clouds. So dry, wet, and we get divergent, and convergent, and divergent, and convergent, and divergent, and convergent. So pressure belts, wind systems, and precipitation caused by all that stuff. Okay, that's it. Global winds. Diagram looks like that. Probably going to assign this to my first period, but my sixth period, I think, went through this whole thing, but they should maybe take a look at it too. Thank you much.